let's see how this works. Share screen. You thought people would be used to that by okay, let me see. I am having a little bit of a trouble. Can I rejoin you in a second? There was some permission issue on my end. Is that okay?
Totally okay. Yeah, go ahead.
Thank you so much. Sorry about that. All right, now you should be able to hear me, and also I should be able to share the screen. Yes, that seems to be good. All right, people, let's get started. So I'd like to talk to you a little bit about, like I said, what makes Java applications a little bit more awesome. My name is Rustam. I am a Google Developer Expert for Cloud. I'm also Java champion. I do speak mostly about Java and cloud, and I am also working as a consultant. So I work in Oslo, Norway. So this is a very, very short introduction about me. This is about Java, not me. So I'll just jump right into it. If you have any questions, please feel free to write them, and I will be answering them at the end. And it's also not only questions, but also comments or anything else that you might want to share with me and the others on the stream. So what actually makes Java applications more awesome? So I decided to do a list of 5 things, but also like good old, programmers, I decided to start with 0. So it's a little bit of introduction first, and then we jump into the 5 things. So the little bit of introduction is that many languages like that are not Java, they have come with some stuff what usually is called batteries included. So you have some libraries and things included into the language that make your life a little bit easier. But Java is a little bit different. So Java is, as a Java platform, it's more of a language and features and stuff like that. But all the libraries and all the other things, they come into the language as a separate thing. So one of them that you might know about is this thing that we've called different names. This has been known as Java EE, J2E. Now it's also called Jakarta EE, and you can see a little bit of a timeline of how it's been developing. And the reason I'm mentioning is that this is this part of batteries being included, because language is a language, but all these things that we know and used quite a bit, probably. I mean, if you've been developing enterprise Java applications, you have been using at least a few of them, probably a lot of those things that you see on the screen. Like I know I started 16 years ago, maybe even more, I don't remember, as a developer, and I was using both GSP and JSF and all those kind of things. Web services. So at some point, we've been all through SOAP, at least if you've been developing for some time. And so JAX VS is one of them. There is a lot of JAX RS, JAX, so if we're doing JSON and RESTful services, so the RS is a thing, dependency injection, bean validation, all those kind of things that we've been most likely using in one way or another. So this is the talk, and the examples I'll be showing to you will be based partially on things that come with Jakarta EE, also known as previously Java EE, J2E. And also I'll be talking a little bit more about something that is built on top of a part of Jakarta EE, and that part is called Jakarta EE core profile. That was introduced in version 10. If I go back, so you can see that the latest version, the last box at the end there, it's the Jakarta EE, and they introduced the separation of different parts of it, because as you can see, Jakarta platform is really big. It contains all kind of things that you may not necessarily need for all of your applications, especially with the modern applications that we'll talk about in a second. So as you can see, I don't know, Jakarta E10 platform has things for sending email or mail and messaging and servlets and what else? Authorization, activation, batch. There's a lot of things that are grayed out here on a purpose, but I would like to talk a little bit more about the part that is a bit more colorful at the right end of the screen. That part is a typical things that you will see that your microservices might need. And also if you're developing modern containerized cloud native, you can call them many different ways, applications, they need this kind of things. I mean, well, obviously you need some kind of JSON binding, because most likely you will be communicating with JSON and RESTful interfaces. You need RESTful web services. You need to do some processing of JSON. You need to do dependency injection, all those kind of things. So that is the baseline for a foundation for a lot of services, right? And the next thing that is built on top of that, on top of core profile, is this thing that I'll be mentioning quite a bit called micro profile. This one brings even more stuff that you need typically in your cloud native applications. So things like fault tolerance, we'll be talking about that, metrics, JWT authentication, health, config, REST client, open API. So if you've used any kind of documentation of RESTful endpoints like Swagger or something, it's typically built on top of open API. It's kind of open API with a pretty user interface, so it has telemetry and all those kind of things. So I'll be mentioning quite a bit of those things in the boxes here as the features that you might want to have a look at. And there is a very important thing. So this is not really, I will be using examples of Jakarta EE and micro profile to show you what you can expect or what you would like to expect. But the important part here is that we will not need to use those things to make it happen, because I will be mentioning things in general that you can typically expect from a modern Java application. So if you're using something else, if you're going for, I don't know, let's say Spring Boot or Micronaut or something else that will help you to do this kind of things, or I don't know, if you're really want to make yourself cry, you can even start implementing everything from scratch yourself, but probably not something I would advise. I mean, there is a lot of libraries that have been battle tested and made available for free to all of us, so we don't really want to do that. If you really want to do something and contribute, I would probably actually advise you to sign up as a contributor to the whatever framework that you're using instead. So let's talk a bit more about this, right? So one more thing I would like to mention is that both microprofile and Eclipse Jakarta EE, they are specifications. So it's up to providers and up to frameworks or runtimes to actually claim compatibility and actually say, hey, you know what? We've tested, we've run all the TCKs, we've done all the tests, we are actually compatible, we support this, and you can use us without any trouble. So it's a set of specification, and like you see here, it's typically a list of documents. For example, here it's the definition of what actually a core profile is. If you want to see and read more about this, there will be links on various sides of the presentation. So as you can see on the right side, on the side there is a very long link, but basically search for Jakarta EE core profile definition or something like that, the specification. Just only one thing is that when you do that, make sure that you use, actually, you find the latest version, because when you Google it, usually you can find several versions. All right, so let's talk more about this. So what I want to do is, actually, I would like to talk a little bit about this, and after I've gone through all of those 5 things, I would like to show you some code. I will be showing some of the code for you in the slides a little bit, just to give you a little bit of context. But since it's an online presentation, it's a little bit difficult to kind of jump between your IDE and slides. So let's do the slides first, and then I'll show you some code, and I'll try to explain how it works. Code on the screen is always fun, and a little bit maybe unpredictable sometimes. So what is fault tolerance, and why do you need that thing? Because we know developing applications. I mean, I'm saying we've been all, because I kind of expect that there is a group of developers listening to this talk on a wide variety and range of experience. Some probably have been doing it for a long time. Some just are in the beginning of their careers, and everything in between. So I started doing I started doing the development using Java in early 2000s. And when we were doing that, we were doing what we call now monoliths, big, huge enterprise applications. And, if there was something would go wrong, the whole thing would typically go down. And, you would have to try to solve this problem of if anything goes wrong, using some kind of caching and all this kind of things. But there was not that much thing called fault tolerance. Yes, there was a really critical applications would typically have it, but typical applications that a lot of us would be developing, then like in the best case, there will be like an if test, like if do I have a is that. Think of this like this. So what happens when something you rely on fails? If a service that you're using, if a service that you want to reach somewhere is down, if the network is down, if the data centers went down on the other end, what do? What happens? Because it can be web services that you have control of, and then you can maybe do something about it. But sometimes that can be also web services that you do not have, endpoints that you don't have control over. It can be, for example, let's say a weather service. I kind of use this example because it's a common service that typically you would not probably have it yourself, but you'll consume it from somewhere. You have a super accurate weather service, but it's a little bit unstable. What do? Well, you have to kind of manage that. Of course, you can put it in your code, like I said, like we were doing in the beginning, where you would have to handle all those kind of things, responses and error codes and all those kind of stuff on your own. But, it's not really fun. So yeah, what options do we have? Well, if something fails, you can either just pretend nothing happened, or you would like maybe to hide some part of your application and make the functionality a little bit less available because, well, it's not there anymore. Or you can, for example, switch to a backup solution. So maybe you can actually very easily define a failover in your application saying, hey, you know what? This endpoint is really good, but it's unstable. If anything happens to it, just jump over to the other one. And you don't really have to write all the code. It's typically, you can expect that. I will show you an example of that in using micro profile and a Jakarta EE. But again, you should be expecting something from a similar frameworks as well, where you can simply just do it with the help of annotation or some kind of configuration. Another problem when something fails is And we've seen that a lot in relatively recent analysis of crashes, is that something crashes somewhere inside your application, and all the other pieces of your application or of your system starts pinging that thing that crashed, and they don't get a response. They keep on asking and keep on pinging, and at the end you have managed to kind of DDoS your own application, which, you know, let's agree, it kind of sucks, and this happened, and it's a little bit tiny little bit kind of embarrassing as well when that happens, right? So let's talk a little bit about how you can solve that problem. So what is it, and how you can help with solving that problem? So obviously you can introduce things like, or you can, again, this is a microprofile fault tolerance spec, and it is implemented by many runtimes or application servers, but you can again expect something similar from the other ones, from your favorite frameworks for creating microservices and stuff like that. You can expect something like timeout, so saying, you know what, if there is no answer within so many minutes, seconds, well, hopefully not minutes, but seconds, do something else. You can specify types and how many and what kind of retries should be. You can also specify a fallback. So if an endpoint fails, if you get not satisfactory response codes or something, automatically fail over to another endpoint. So if we're thinking of the weather example, is that, okay, super accurate but less reliable endpoint, and then you have a more reliable but less accurate one. But, you know, for the user, maybe it's better to get a little bit less reliable result than getting an error in their faces. So fallback might be a very good idea. Circuit breakers are a very nice feature to think about when you don't want to DDoS yourself. So, you know, you can say, look, if you've tried so many times, and if this happens and that happens, you know, activate circuit breaker, just kill the whole thing. We'll get back to that later. And there is also things like bulkhead and synchronous as well. A really quick example of how it might look in the code. We'll look in the code in a bit, but this is an example. So imagine that we have a REST endpoint that is, you see, it's we're doing here register REST client, base URL, localhost 8080, because it's just in my machine. A path is /API, so it will be 8080/API. And then I have a message service. So /API/message would actually go ahead and do something. And get that data method is the one that it's a web service interface, but it's implemented somewhere else, and it will actually retrieve some kind of data, right? And also, well, we're also telling that, you know what, it's going to return a JSON, produces JSON, and so on and so on, right? But the most important thing probably in this context is this part called fallback. So here we're actually defining a fallback method called get that other data. Very creative names, I know. I've been really working hard on those names. But, you know, when you create demos, right? This is our backup message. So we have a path called message backup that actually can run a backup service and return a different kind of data. So if get that data fails, it will just go get that other data method. We'll see that in a demo in a few seconds or minutes, or a little bit in a bit. To explain you a little bit more of the behind the scenes, what's happening there. So if we go here, so get that data and get that other data, that's the things that you see here. So external services. So I have implemented a flickering service. Basically, what happens is that you roll a dice, and if the number that you see on a dice, so you know it has 6 sides, and if you divide it, if it's divisible by 2, then it's good. And if it's good, then you actually send an OK message and you say a message hello there, which is a string defined up here in the beginning of the method. But if the dice rolls on any number that is not divisible by 2, well, then you do some weird error. So then you do a response server error, media type application JSON, and you actually return some weird error. But as you can see, as you will see on an application that I will be showing you, you will never actually see, or as a user, you will never see that weird error thing, because we have defined earlier here, right? We've defined failover. So what will happen actually, it will go to this API backup message service and return a backup hello. I put a backup in the text simply because then you will actually see that we're doing something different. Okay, so that's failovers, right? And then let's talk a bit about health. Let's talk about let's talk about what actually happens inside your application. So health is a way of having a look into your application and making sure that everything is doing fine. How do you do that? Well, there is a few things that you would like to know when you containerize your application and when you make them run inside a container somewhere out there in the cloud, on a local like private cloud, or even your local data centers, in Kubernetes, in serverless applications. Doesn't matter. The point is, you sometimes want to know, or actually very often want to know, how your application is doing. And there are a few things that you would like to know. So when we have a containerized applications, a few things happen before it's able to respond to a user. So first, you will need to make sure that the container is up and running. And then you will need to also make sure that the application within the container is up and running. And then you will need to make sure that everything is good and your application is getting access to whatever it needs to run, like, I don't know, a database server or something. So there is a bunch of tests and different probes, as you can call them, that need to be in place to actually know that your application is healthy. And it is also a thing that is being used for scaling, so automatically by things like Kubernetes and similar. It will be using that for knowing whether your application is good or not. Is it ready to receive requests, or should it wait a little bit? Or maybe, is it alive and well, or is it hanging and needs to be the container needs to be scrapped and restarted again? So there is a lot of different ways that this can be useful. How do you do that? Well, there are different types of probes. And again, this is as you can see at the bottom there, this is an extract from microprofile health spec. But again, you can expect something similar other places, because this is more or less a standard for Kubernetes and stuff like that. So there is a readiness probe, basically saying, are you ready to serve requests? There is a startup probe saying just, hey, I just actually started up, And liveness is more or less just saying, look, okay, I see that the application is said it's up, and I see the container is up, but are you actually alive? Are you able to do something, or application is saying it's alive, but it's just hanging? All right, so we'll look more into that also when we get to the code. I will show you how it's done and how you can implement your own things. I have a few examples of health where I use different various metrics to measure that, like things like response codes from HTTP, like is it 200, or is it something else? Also, I do, what do? I do measure response time and say, look, if the response time is above a special certain threshold, then you're not doing well. Then you need to be restarted and you need to be redeployed and so on. Okay, so health is one thing, but also there is it's about how your application is doing. But now I'd like to talk a little bit about another thing that we need a typical cloud native applications that, again, we have been developing and creating that earlier and previously, but before it was a little bit more specialized. Now there is a lot of tools and stuff that can read from that, and you can actually automate a lot of things, and that's really, really nice. So metrics is a way of measuring, is actually not if your application is alive, but more about what it's doing and how well it is doing those things, or how much pressure is it on it. So you can create custom application metrics and expose them through a standard format as a platform, as those metrics, right? And that's really, really nice. How do you do that? Well, or actually, why do you need that first, right? First, well, let's talk about why do you need this. And this is, like I said, you want to measure custom parameters. You want to measure, let's say, how often your method endpoints is being called, like simple thing, right? Just counting things. Or you want to count how many times your failover method is actually had to kick in and help. If you think of this, my failing application saying hello and backup hello, I want to measure, for example, how many times you call that API at all. I can do that for just fun and statistics and knowing actually how many people are using it. But I can also do that, I don't know, maybe I can do some kind of billing or something, right? I want to know how many times that particular user is using that particular thing that might cost that user a little bit every time you call it, or anything in between. But you can also measure times something fails, and you can expose that, and you can see, and you create alerts and dashboards and saying, look, the number of failures is increasing, so something is going wrong, so we can actually act on that before something really, really goes bad. All right, how do you do that? Well, a very simple or starting point would be to start counting things, right? This is kind of what we're the first thing we learn when we're small kids. We start to learn to count, and this is what we can also teach our application to do, and saying, look, I want you to count every time that thing is being called, and I do it with just annotation, and I'm going to give you a name. I'm going to say what kind of, if it's going to be an absolute value or not. And I'm also going to give you a tag, so I can actually find it in the million of other things. And I can separate those by different tags. So for example, I will show you in a bit tags where I'm saying a success or failure. So then I'm actually using the same counter, same value or anything, but I still use different tags, and then I can actually see the difference. What usually also happens is that when you use frameworks like this, they will typically expose everything. So you don't have to, for one, you don't have to implement all the counting and all the kind of the bookkeeping. Two, you do not have to expose all that. You will be exposing that automatically. The thing you probably need to think about is that how do you, with all those things, with health and metrics and all these things, is the security part. I haven't mentioned that until now, but I probably should mention it. You probably don't want to expose it to the whole world, both metrics and all this. I mean, it kind of sounds very obvious, but you'd be surprised how many people just forget about it and just expose a whole endpoint. And then you're like, hey, I can actually see how internals of that application are doing and stuff like that. Maybe a little bit bad idea. Okay. Another thing that I want to talk about is something that is very different. So this is not part of any Jakarta EE or microprofile or anything else. It's typically a feature that is being supplied to you by a third-party application, and typically think that technically you can implement yourself like all the other things, but like all the other things that I've been talking about, you really don't want to do that because it's a lot of things. And I've been doing this talk earlier, a few weeks or months ago, and somebody asked me a question. They were like, hey, look, I have a question. This thing you're talking about, do we really need a system, or can't we just do a bunch of if sentences and if and else and if else and all that, and just implement all this feature toggling? Yes, you can, but do you really want to, or do you really want to have all that in your code? So I'll show you again one example. So all the examples I will be showing, they're obviously going to be opinionated because I had to pick something to show you a demo, but you can again use different tools for that as well. So what is toggling? Let's talk a little bit about that. Feature toggling is a process where you make an application available for everyone, but you can control set of features that are available. So sometimes you can just turn off and on some features that should be off or on for everyone, or you can do it based on different other parameters like geographical location or anything else. Why do you want to do that? Well, sometimes you create an application and sometimes you're not just done with parts of it, but you have already implemented the front end and you have already implemented part of back end, but it's not really working. It's failing some tests. It's doing something wrong. You're still not really happy to release it. What do? Do you actually say, you know what, hey, I need another 4 weeks to finish that. So, well, that release, that's not happening. Sorry, not sorry, let me finish my stuff. Well, obviously, probably not a good idea, but you can also, what you can do is actually to implement a feature toggling and say, look, that feature is not ready yet, but it will be released soon. But for now, we're going to just flip it off and take it down. Another way of doing that can also be, for example, if you have developed some feature, but for some reason, for one or another, your customer still does not want to release it because maybe they want to release it at a very specific time, or maybe they are not really ready to take take that feature available because of some other reasons, because something is happening and they don't want to make it available just yet. Or maybe it's I don't know, Black Friday feature, so you want to make it available on a specific day, specific time, and turn it off at specific time. So all these kind of things, or actually it can be also. Now I've been talking a lot about making features available to everyone at the same time, but at controlled times. But maybe you can actually do gradual releases. Maybe you want to you want to create something that will only work for I don't know, maybe it will only work for 5% of your users, and then after a little bit of time, it will actually you will test it, you will see how it works, you will see what is happening, and then we can make it available for more people. So 5% of your users test, see how it works. Okay, cool. Then we'll turn it on for more users. Or you want to say, make it available for a geographical location. So you want to make it only available for users in India, but not in Norway. So then you can actually do this kind of stuff, right? Okay, what else? Yeah, partially implemented features we talked about already, so don't really need to mention that. Well, how do you do that? Well, we talked a little bit about this already, right? Obviously, you can do it by hand, but you shouldn't, because it's a lot of work and you don't want to put all those ifs and elses inside your code, because you will have to remove them later. Otherwise, your code base will look very unmaintainable very fast. You can obviously also put it into a configuration file, which is another nice way of doing that. But that's how we typically used to do it for a lot of applications before. But again, configuration file is nice, but very often it will require some kind of reloading of the service. It will reload maybe application to read that config file, and you still need to handle a lot of things manually, reading from that config file and turning on features and off, and so on, so on, so on, so on. So config file is maybe not a good solution as well. The better solution is to use a tool. And the example of one of the examples for such a tool is Unleash that I'll be talking about. I'll show you in a little bit. And the cool thing is that you pretty much can do feature toggling like this. So at the right bottom corner, you see a user interface for that Unleash interface, where I'm actually showing the feature called, what's it called? It's called Chaos. And I can make it available in development, or I can make it available in production. And when I do that, I can actually, in my code, do a little bit of checking with very little extra code and very little, I mean, still, it's if sentences and if clauses and stuff, but it's very, very simple. So I do if unleash.isEnable, and I provide a name of the feature that I want to check. And if it is enabled, I return, so it's called chaos, right? So if chaos is enabled, I actually say it's a feature. And if it's not available, I can actually call it the way it should be called. And I say, you know what, it's actually a bug. This is a very simple and stupid example, but that illustrates you the point of how simple it is to get hold of features, and also how easy it is to flip a little switch on a website, and in a few seconds it's all available to all of your clients all around your ecosystem, applications, world, you name it. It's actually an open source product. That's one of the reasons why I kind of dare talking so much about it, and all the other things that I talk about, they're open source and free to use. You can buy a cloud version of this and pay them for that. But if you don't, you can actually just download the code and set it up yourself and make it run and manage it yourself. So that is that part. Last thing I want to talk to you about is a big bag of various things, right? So it's a big bag of things I called environments, configuration, and infrastructure. And that is a thing that we often forget, because it's something that we need to do. We just do it real quick, and we would like to actually go back to coding and go back to all this kind of things. But it is actually a very important part of your development project, and really, really important part of making your applications nice and robust and cloud native and cloud friendly, or call it whatever you want. Before we talk about that, I would like to say one thing first, and that's very, very important, because in most of the cases, no matter what you do, this term that will come up on the screen very soon, that is very often is used in connection with cloud. But it doesn't have to be cloud. It can actually be also on-prem. It can be private clouds. It can be public clouds. It can be anything. But it is a thing that we very often tend to do, and that is ClickOps. So first of all, whatever you do, if you want to start with anything at all, stop doing ClickOps. So if you want to set up an environment, if you want to set up your, I don't know, let's say you want to set up your application to run in a application server or runtime, right? Typically would be like, okay, open your runtime, whatever that is, log in, go to administration, set up HTTPS, do this, do that, deploy your application, drag and drop. It's very nice and very easy. You do it also with the cloud, right? You create a new project, create a new thing, deploy your application here, create a file that will create a pipeline for CI/CD and so on and so on. It's very tempting to do that with ClickOps, but to not do that. Actually use something that will automate that process so you don't actually even have to touch whatever you're deploying on, but you actually provide a file and tell it, do it. Why? Because it's actually a very important thing, because it's actually making it reproducible. So if you've done it and tomorrow you call in sick and you say, look, I can't come to work, I'm really feeling really bad, my head hurts, I can't move, I need a few days to get better, a colleague of yours has to take over. And that colleague does not have no idea what you've been doing yesterday, and it can't reproduce the whole clicky thing, because maybe you've clicked something really smart, you found a solution in documentation or on the internet, and you figured out that to make it work smoothly, you need to tick off that little box. That poor colleagues of yours doesn't know that. And if you haven't put that all into a script that is actually reproducible, it will be most likely some kind of failure or some kind of error at some point. So in addition to being actually reproducible, it's also a documentation. Think of it as that, because it's actually documented in a way that you can actually go through that script and know exactly what has happened and when and how. And if you run it again and again and again, you'll get the same results. And obviously, it's going to be automated, right? Because you've created that file. There will be something that will be reading that file and will be executing all that. It's not all just like happy, joy. I mean, it's a little bit of a cons there as well, because obviously when you create something, that thing needs some time, love, and care. It's like you need to take care of that. You need to make sure that it is updated. It needs to be maintained, and all this things that are related to that. So maintenance of that scripts and text files or YAML files or whatever that is, the way you actually decide to do it is an important part. And there are different ways of doing that. So let's talk a little bit about that. So one way is doing the infrastructure as code. So setting up infrastructure, that is typically something like Terraform or Pulumi or something like that will do that. There is also management of your servers and of your applications and stuff. So I don't know, things like Salt Stack or anything else. Like, there is a bunch of different tools that Ansible, right? There are a bunch of different tools that can do and can help you with several various ways of doing that. So infrastructure as code is actually setting up a lot of things, and then you can continue with Terraform and Pulumi, or you want to or have to use some other tool. That's totally fine, as long as you actually do that and automate that. When it comes to configuration, there will be a typical framework or something that will help you with that, because you need configuration. So when you create containers, or when you create applications, jar files, whatever that might be, you need to configure them to run with different parameters based on whether it is a production environment or staging or development or anything else. You need to provide different URLs to different servers or IP ranges or usernames or whatever that might be. And all of that you would like to actually put into configuration files, so you can just deploy the same artifact to test it in different environments, but you actually provide different configurations files so that will actually set it up in a different way. Another thing that I would like to mention here is that think of when you create an application and when you want to create a cloud native, awesome, fantastic application, is that you need to think where it's going to live. You have to think about its new home, and that might be public cloud, private cloud. It can be on-prem solutions, doesn't matter. But the thing is, All of those solutions would typically have something with infrastructure as a service, platform as a service, maybe good old VMs that you need to do. Maybe this application is super strange and weird that you really need to just rent compute and memory and just put a VM on it and actually deploy it there. But maybe it is so easy to handle and so fantastically cloud native that you can deploy it on a serverless platform. So it will be scaled up and down without any issues and any problems. Maybe it's a Kubernetes, and maybe you really do not need a Kubernetes service to run your application because, Kubernetes is not a solution every time you need to run something. Sometimes it can be a perfect solution. Sometimes it can be very wasteful solution in terms of spending a lot of resources and all that to run that application. So I mean, there are different aspects to that. Obviously, first of all, it's money, because if you run a application that requires less resources, but you're spending a lot of resources and running huge Kubernetes cluster with 3 nodes and all that to make it work, you're wasting quite a bit of money, but you're also probably wasting some environment on that as well, because you're wasting energy to run, well, nothing. Maybe you want to do that. So, money, environment, is that reasons enough? Your time, fun things, sometimes you want to deploy things and actually have fun, and deploying things to serverless is kind of cool because you can just deploy it there and it's going to sleep, and then it wakes up, does the job, and goes back to sleep, and it's kind of really nice. It's kind of cool. When we talk about automation, one more thing is worth mentioning, and that can be very, very pleasing for us as developers, and that also applies to applications like this as well, is to automate as much as possible of the CI/CD pipelines as well. So you want to automate testing, deployment, also all the things based on different environments and stuff like that. So maybe you want to, I don't know, let's say you want to deploy to different environments based on branches or based on tags or based on some kind of promotion thing. Do that and automate that, and you as a developer will thank yourself. Future you will thank past you for doing that. I've done that many times. I was like, oh, do I really need to do that? And then I've done it, and I'm so happy every time I do a git push, and it just automatically appears deployed on somewhere, and I don't have to go through all those things. So then you can actually sit and watch that little thing to spin. And when it's done spinning, you can just eagerly go to URL and it's like, it's a new bug. And then and then have to fix that. So you can actually spend time fixing bugs instead of deploying it. All right, so let's do a little bit of a demo. Before we do that, is there any questions? Are there any comments, anything that we would like to do, or we would like to jump into the questions? The demo, sorry.
Yeah, I think, yeah. So we'll go ahead and do the demo and take the questions at the end.
All right, okay, let's do that. So I will let me see, I'll stop sharing this part, and I will go over and share my IntelliJ, which is here. Share. And there is one thing I need to do. So I've been told that we really like light themes better than the dark themes when they're in the presentation mode. So I will do that. So right now you should be seeing 5 features talk demo applications. So if you're not seeing that, please shout out in the chat. And also, most probably question to the organizers, how is the size of the font and everything? Do you want me to make it a bit bigger? How it's looking?
No, I think it's good. It's good. I mean, this is
okay.
Perfectly okay. Yeah.
Okay, perfectly okay is good. So if it is not okay for you, please do a quick shout out and we'll fix that. All right, so let's see, Podman. So a little bit about setup here. So as a good old geek that I am, I have created a bunch of, let me see, README files. And README file is contains also documentation. And speaking of being a geek, I obviously ended up writing a documentation in ASCII. So what I've created now, I have created two web services. I call them a service and backend service, and sometimes I even refer to it as a front-end service and backend service. It has nothing to do with web front-end. It actually basically means that there is one web service talking to another web service, and we as a users always reach out to that particular web service, right? So let's see. What I want to do is actually, let me see if I can do that. I would like to pull it over to this screen, and then I would like to, let me see. I'll do a little bit of restructuring. So I'll share my whole screen, desktop 1, share, because then I can actually switch between windows. So now we have, ooh, that's fun. Changing resolution is always fun. Okay, let's see. Okay, we're back. So, right. Okay, we have, so since I changed resolution, please again, shout out if it's too small or big or, anything. So we have a service A and service B. Service A talks to B. And whenever I go to an endpoint at /hi, it will go to API message. And if the message fails, it will actually do a backup message call. There is also an endpoint called feature, and both of them. And that's I use a little bit of that code that you've seen earlier that kind of turns a feature to a bug to demo feature toggling. And this is pretty much it when it comes to those two services. In addition to that, on my network here, I also have an Unleash service that is a feature toggling service that has a few features that call feature, chaos, and delay. The way I actually do that, I have a compose file, Docker compose file here, and I also need to pull up Unleash as well. So go Docker compose up -d. So this is Unleash server that will be, okay, let's see, Podman PS. Okay, so all of them are actually up and running. Perfect. So that also means that I can go to here and say localhost. Let's see which 8080. Let me see, 9081. So that's my demo service that is running on 9081. So I can actually go there and say 9081/hi. And it actually keeps on returning hello. But as you can see, let's see, localhost 4042, that's my Unleash server. So admin and right. So what we have here, we have a chaos variable on. Oh, come on, go away, all the pop-ups. And then we turn them all off. So now all the features and all the things are down. And now as many times I will refresh this thing, it will actually keep on saying hello there, because here is my, here's the code that you've seen earlier. This is the rolling of the dice, but it only happens if the chaos is on. And chaos we actually did turn off. And I also have another feature here called delay that will basically, all it will do, it will take a power nap of 5 seconds and then go back to work. And all this is done with annotations. Look, I mean, I haven't written much of any other code, any other things that my actual logic of my code, and I just provide everything with annotations. So I actually created a path called API message. I have metrics. We'll talk a little bit about that in a second, but this is my custom counter to see how many times it's been called. I also have documentation, so that will be used by OpenAPI later, saying, you know what, well, this is a main messaging service. It may be slightly unavailable at the moment, or unstable at the moment. And that's because, you know, sometimes when this happens, it will be unstable. And without all that, it will still run, but it will not do all the fancy stuff that I'm doing. And this is my backend service. To my front-end service, I have a REST API, REST client that will go actually, so create this. I have this class called my message that will return this information, my fancy message class and message. That's basically all these things that we've seen here, right? So hello there is a message itself, and then I add all these fancy things to it in this class. In addition to that, I have the demo app here that does this failover thing, right? So right here. So we do actually, so I defined register REST client. So now I'm actually pointing at the backend service. This is my front-end service, remember? So we're actually pointing to where the URL for the backend service is. Notice that it's a different name and different port. That's because all of that is running on the Docker Compose. So I'm actually not using my local machine that I'm mapping all the ports to, but I'm actually using the internal network that is created between the containers. And here's the failover as well. And this is the thing, right? Fallback, we talked about this. We've seen that code, and this is my message backup. So if we go and turn on the Chaos Monkey, we can do refresh, 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 refresh. I hope you're seeing that I'm refreshing. Yes, there it is. A backup hello. So the dice was rolled to something bad. Refresh, 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 refresh. Yeah. So this works. Okay, let's have a look at the feature thing. Well, it's a bug, says client. Okay, we can do something about it. We can do that here. We turn on our feature tagging service. And all of a sudden, with a simple movement, it's a feature. So you see, I don't do anything with my application. I just go into another thing. I flip a switch, and all of a sudden, within, I think, like 5 or 10 seconds, it's available for all my clients. And the same will be also if I change this to port 9082, that is my backend. You see, backend. It also says actually it's a feature. And if I, well, flip it off again and refresh, it should become bug very soon. It usually takes like 5 to maximum 10 seconds. There it is. And now I can refresh as many times as I want. It still will be a bug. So how do you do that? That's also kind of cool thing I would like to show how simple it is. So in typically somewhere I need to instantiate an object called unleash which I use for, so I create an unleash config file and then, class, and then I define it like what's it called and instance name and where the unleash server will be found and all those kind of things. And also API key. So typically you will have an API token. Since I'm using it in local network, I have just the default thing. Now I have made available this unleash object, right? All I have to do now is just say unleash dot is enabled and whatever I want to do. And if I want to look at all the other things it can do, it's quite fun. You can do a bunch of things here. That's one thing. Okay, let me see. I have a little wiki file that I've created to remember all the things that we can talk about. So at least some of those things. So we fault tolerance, we talked a little bit about that. We've seen the demo. I would like to talk a little bit about health. So health package, and this is the part that remember what happens inside your application. And that is different kinds of checks. Now I see that we're running a little bit low on time, so maybe I'll be very quick. So health. You see the backend is very simple, a health application, thing. It just implements the very simple, has application started or not. But my front end is a bit different. So here I have a bunch of things. I have actually liveness probes, a different one. So that one that checks for response time, it checks, I can tell you, it checks if the response time is over 3 seconds. And you remember we had a delay thing that actually sleeps for 5 seconds. So let's see what happens when we turn that on in a second. And then it has a HTTP response code, also checking if it's actually responding well or not. Health checks, and is if application is started. So delay on, and let's see what happens. Refresh that thing. It's going to hang for a little bit, so it's loading now because all my requests are actually taking more than 5 seconds. I need to actually wait for 5 seconds for it to fail. And apparently it's actually saying, look, your service is too slow. And the way you do that is just to do a little bit of quick show you how to do this. This is where it happens. This is where the magic happens. And the way you do that, you just, well, here I just do system current time and check if the current time is less than 3000 milliseconds, so 3 seconds. And if it is, then everything is good. And if it's not, then it just fails. And then you can do the same things with different HTTP codes. You can also do a very simple kind of check for pinging server. You do a ping server. If it responds you with OK, then you're good. If not, you just fail. OK, let's go very quickly back. So metrics. Oh, metrics is fun. I want to show you metrics as well. So if we go /metrics. You see all this data, you're kind of having a wall of text in front of you. And that is, no, I want to go to the backend. So backend is 1982, and this is my custom messages. You see it says application custom messaging service total. And I see how many times it's been called and how many times it actually failed. So if I go to this hi message again, oh, I need to turn off the delay thing, because otherwise it will take so long. Okay, come on. Refresh. Oh, come on, man. I turned you off. Okay, now we're actually doing. So now we've run it a few times. Remember, it was 30 and 92 here. We refresh, it's now 30, 33 and 100 times. So basically it says that it's been called 100 times while I was doing this demo and refreshing it. And 33 times of it was actually a failure. So you can create those kind of things as well. And the way you can do that is, like I showed you, it's here. So you just do add counted, you create a name, and you do the tags and stuff. And tags, the ones you see here, purpose failover, purpose total. Okay. What else do we have? Feature toggling, I showed you that already. And there are some links for environments and configuration infrastructure and all that. So that's all that I probably have time for you to show you. But if you have any questions or if anything, I will, let me see, I will go back to here and I will show you my contact information. So this is how you can find me on Twitter. Feel free to ping me there and give me a follow, give me a shout out on DM or public as you might wish, and we can discuss there. And if you have any questions or comments right now, feel free to ask them now. I don't know if you have time for this.
Oh yeah. So Rustam, you have slightly over time, but fantastic session.
Thank you
we
so
won't
much.
have time for questions, but still, would like to really thank you for a brilliant session because I think the prioritization did it right. So with just five things to look at, 5 the most important things to look at.
Thank you so much.
I think it focuses your mind, and then releasing to production for an application that is very, very transactional in nature, that's already running, like, let's say for 2 years, you always have the feeling that you're walking on eggshells, right? So it's never a very comfortable feeling. I mean, to be able to do the feature flags in a manner that is so simple, without having to use those fancy tools. I think that's a revelation. So thanks for a brilliant session. Thanks for
Thank you
taking the
so much.
time and doing
Thank you
this
for
with us.
kind words. One thing I would like to mention, just one real quick thing. When you do feature flags, please, and I really beg you, please remember to remove them when you don't need them anymore, because otherwise you will have a very big mess of a system.
Right. Yeah, got that. Yeah. But again, thanks a lot. And
Thank you so much.
someday soon in the future, we'll hope to bring you back for another session.
We'll be glad to do that. Thank you all for coming. Thank you all for having me. Thank you very much.
Thank you, and have a good flight.
Thank you.
Bye-bye.
Bye-bye.